Are you able to see my screen?
Yeah.
Okay. So, so cloud computing. So, what are the challenges today that's been faced in the industry? First, there is a scalability issue. There's large scale data, there's high performance computing, and there's the cycle of obsolescence is shortened. There's rapid changes in requirements from users, from the society, from business perspective, and there's data from so many diverse sources from which we can gather information and use it in our systems. So for doing all this in a cost effective manner, we use cloud computing. So what exactly is cloud computing? It is the internet based computing whereby shared resources, software and information are provided to computers and other devices on demand, just like the electricity grid. So it is it is the culmination of numerous attempts that were made at large scale computing with seamless access to virtually limitless resources. So there are typically three models of cloud computing. One is platform, software, infrastructure. And a cloud computing environment can provide one or more, like there can be a mixture of these for a cost, and you can pay as you go, meaning that you don't have to pay when you're not using the resource. You pay only when you're using the resource. That is called on demand computing. A public cloud can be compared to renting a property rather than owning one. And an organization can have a private cloud and can use a public cloud or both. So, some basic concepts. So, there are two kinds of models for cloud computing. One are deployment models, second are service models. What exactly are deployment models? They mean what kind of access is provided to the cloud. It is of four types: public, private, hybrid, and community. So, public cloud is available to the general public. For example, Gmail. It's less secure because of the openness. Private cloud is private to an organization. Community cloud, which is accessible by a group of organizations. Hybrid is a mixture of public and private cloud. Service models. So service models are of three types: platform as a service, software as a service, infrastructure as a service. So this is like the pyramid like structure. um, Infrastructure as a service comes at the bottom, where we provide on demand scalable infrastructure as a service. And there can be VMs, there can be physical machines, there's virtual storage. All this comes as infrastructure as a service. Examples are AWS, GCP, Microsoft Azure. Platform as a service provides runtime environment for applications, for development, deployment, everything, for the entire life cycle of the product. And examples are AWS Lambda, Elastic Beanstalk. Software as a service are user end applications which are provided. They're multi-tenant. And examples are Google Apps, Microsoft 365, Office 365, Slack. All these are software as a service. Virtualization. So, what exactly is virtualization? It is an abstraction of an execution environment that can be made dynamically available to clients. There's a resource quota, there's software configuration, and it is an abstraction of a physical host machine. The benefits of using virtual machines. Whenever a user doesn't have the physical hardware for running an application, uh, he can just take up some virtual machines and use them for application deployment, development, whatever. It's easier to scale, it's easier to create backups, it's uh, easier to emulate more machines than they're physically available, and there's easy migration of virtual machines. So what are the purpose and benefits of cloud computing? So cloud computing enables companies and applications which are infrastructure dependent to be infrastructure less. By using cloud infrastructure pay as you go model, a company can save a lot in capital and operational investment. Benefits, there are multiple numerous benefits. First is cost saving. Second is scalability. Is it's easier to scale. The user doesn't have to get into the overhead of scaling. There are services for that specifically. It's more reliable. Maintenance is easy because cloud providers do system maintenance, and the user doesn't have to do anything. So we talked about all the benefits. Just think about what challenges are still present. First is security. When everybody is using the cloud, and that there might be cases where unauthorized users gain access to your confidential data. So security is a big concern. Although there are services like IAM access roles which are present, which um, assign access to a particular resource and other users cannot access that particular resource, but there's still security concern. And obviously your data is on the cloud, it's replicated across multiple machines, but it might be lost sometime. So you do not have a backup of that data. Going into GCP is one such big player in the cloud computing providers. There are four kinds of services that GCP provides. One is compute, storage, big data, machine learning. This is a chart representing all the major services that GCP provides in each of the categories. Talking about compute services, there's compute engine, which provides virtual machines, which are hosted on Google's infrastructure. So this is an example of infrastructure as a service. There's app engine, where you deploy your code directly to a fully managed platform, which is an example of platform as a service. Container engine, where you can run Docker container clusters on GCP, and this is container as a service. Storage services, Cloud SQL, Cloud Storage, Bigtable, Cloud Data Store. All these are examples. Cloud SQL provides full SQL support for an OLTP system. Cloud Data Store provides a storage for structured objects, and you can query with SQL-like statements. Cloud Storage provides blob storage, where you can just put in any kind of data that you have. Cloud Bigtable is basically a NoSQL database. It's highly performant and highly scalable. Some data processing or big data services, there's Dataflow, there's BigQuery, PubSub, Dataproc. BigQuery is data warehouse, analytics warehouse. Dataflow is for stream and batch processing of data. PubSub provides a messaging queue service. Dataproc provides managed Hadoop, Spark, Hive, all these tools at affordable pricing. Some machine learning services that GCP offers are Vision API, Speech API, Translate API. So we listed all these multiple services that GCP offers. How can you access them? How can you interact with GCP? You can do that in four ways: through the cloud console, through cloud SDK or the cloud shell, through the cloud console mobile app, or the REST-based API that GCP offers. Now moving to Docker. So GCP also provides Docker as a service. And what is the need for Docker? So nowadays, the applications are designed in a way that they're broken down into microservices. Every operation is a separate operation, and the scaling is not a problem. There's no single point of failure. So earlier, what used to happen, there was one application on one physical server, like you can see here: operating system and application. So what were the limitations? There were slow deployment times, there were huge costs, there were wasted resources, there was a difficulty to scale, there was a difficulty to migrate. Then came hypervisor-based virtualization. What it does is it provides multiple VMs inside a physical server, and there's guest operating system in each of those. Benefits is there's better resource pooling, easier to scale, but there's limitations still, related to the fact that the guest OS means wasted resources. The more VMs you run, the more resources you need, and the portability is not guaranteed. What is a container? So container is provides standardized packaging for software and dependencies. Like you can see, it uses the same kernel or same OS kernel, but it isolates apps from each other by packaging the software and its dependencies, and it works well with major Linux and Windows operating systems. This is the comparison between containers and VMs, where here you have a different guest OS for each of the applications. This uses the same operating system, and it just packages them into different containers. Benefits of Docker containers. One is the speed is higher because there's no guest OS, and there's no applications are online in seconds. You just run the image, and there'll be container, and you'll have a running application. It's portable. There's less dependencies between process layers, and you can just move between infrastructure. Efficiency, there's less OS overhead, so it's highly efficient and improved VM density. Some basics of Dockers. What is a Docker image? It is the basis of a Docker container. When you have an application, and that application content is at rest inside, wherever you're creating the Docker, wherever you're using the Docker, creating the Docker file, the content at rest is an image. When you run the image, it's a container. Docker engine is what is the software that executes commands for containers. Registry is what stores, distributes, manages Docker images. Control plane is the management plane for container and cluster orchestration. So now we'll get started with an introductory Docker lab. So this is the introduction to Docker lab, and this is a pretty introductory lab, and you don't need any prior experience with Docker for going through this. Here we'll build, run, and debug Docker containers and pull Docker images from Docker Hub and Google Container Registry, and we'll push Docker image to GCI, which is Google Container Registry. So did you all start the lab? Did you get access to this page?
I think it will take some time for them to actually get to this platform.
Okay.
You can go ahead. I think
Hmm.
anyone is facing an issue will take care in the chat itself.
Okay. So we just open Cloud Console. Okay. So this is the Cloud Console, and here you can see this particular icon will activate my Cloud Shell, and I can give commands here directly and manage my Docker images, containers, everything directly. So let's start with this. What list? This will give me my account information. So, right. You guys should be able to do this in some time. And this is the project ID that we are currently doing. So let's see. There's already an image called Hello World present. So we will run that image. For now, this says that it's unable to find the image locally, so it pulls from the library. As you can see, the pull is complete, right? And this is the output from that. So now what we do is I check all the images that are present with me locally. This is the image that I just pulled, the hello world image, and I'll run this image. Like I told you, a running image is a container, right? So this started my container. Docker PS lists all the running containers for me. Right now, as you see, there's no running container. Why? Because the container ran and then it exited when I ran this command, docker run. So if I want to see whatever containers were there previously which ran and exited, I have to do a docker ps hyphen a, which gives me, see, these were the two containers that ran because I ran the command 2 times. And let's build a docker image now. I'll create a directory and I'm making a test directory and just cd into that. Now we create a docker file. So what is a docker file? It mentions what are we doing here. Okay, so it's using this base image. There has to be a base image and then you have to add logic to that, you have to add layers to that, and you do that in the docker file. So this is the base image. I'm setting the working directory and I'm adding my current directory contents into the working directory, right? And I'm exposing a port. Exposing a port means on which port will this container be accessible, right? This application will be accessible. So let's just copy this entire thing and paste it here. Okay. Now this was my docker file. I also need to create the application, which will give me some content which will run and give out an output to me. So I'll just create an app.js file, and as you can see, I'm just returning hello world from here, and I've mentioned the same port here, 80, and it's available on localhost. Host name is 000. So I created this app.js file, and now I build the image. So these are all the base images. Like you can see, it says pull complete, pull complete. These are the base images from here. Now this is successful. Let's see how many images we have. This is the image we created. We gave the name node app, right, while building. So this is the name, and this is a new image that we've built. So now let's run the container based on the image that we built. What is this command doing? Docker run hyphen p. Hyphen p means I'm mapping my localhost port 4000 to the container port 80, right? I mentioned the container port is 80, it's accessible on this port, and I'm mentioning 4000 for my localhost. And this is the image name, and the app will be called my app. You can give any name here, whatever you want. So this is server running at localhost. So let's see what output we get when we do a curl. So I'll use a different terminal here. So you get the output that we mentioned in the Node.js file. So now let's just stop the application and remove the Docker container. So right now, what happened was when you ran the image here, ran the container here, it was running here, it was not in the background, and you had to open a new terminal here to do a curl or whatever to stop it, right? So what if you want it to run in the background, you want the image to run in the background, so you add this -d flag, which will tell it to run in the background, and you can just carry on with the other tasks that you're doing. So, right, if you want to look at the logs by of a, of a Docker container, you just do this Docker logs and the container ID. So you can get the container. This is my container ID. I just copy it. So I'll do a Docker logs and then container ID. And this is the only log that I've mentioned there. So this is what I'm getting. So let's modify the application that we wrote initially. Let's modify it. So what do? We go into the directory we created and we modify this. So initially we had written. So how do we modify this? Just use an editor of your choice. I'm using Nano here. So earlier we were returning hello world. So let's just say we change it to welcome to cloud, right? And we save it. Now we build the image again and we name it 0.2. Okay. So it's built. So now we built the image. We need to access the application now. So we have to run the container. And as you know, port 4000, we were using port 4000 for the earlier 0.1 version of the application. Now this is, and that is already in use, right? So we've mentioned another port here, which is mapping again to this port 80. And that's how I'm running. So you can see there's point 1 and point 2. Both are present here. Let's just do a curl for 8080 and we get welcome to cloud. So this is the second container that's running, as you can see. If I do a curl 4000, I still get hello world because my previous container is already running. So I made change to an image and I created two different containers out of it, and both are running, and I'm getting output from both of those. So when, let's say, a container is running and you want to look at the logs, what you use is -f. This flag gives you logs from a running container. So I'll do a docker logs -f, and this is the container ID. These are the logs that you get from a running container. If you don't use -f, it'll be for exited containers. What if you want to access an application, go inside a container and access it using bash or whatever shell that you want? So what you do is use this command exec-it and mention whatever shell you want to use. So I have to give a container ID here, and I pick the container ID from, this is container ID I'm using. So as you can see, we are inside the container now, right? Let's do an ls. Let's see what all is present inside the container. These are the two files that we created, if you guys remember, the Docker file and the app.js file. So you can do anything that you want inside this. You can create other files, you can make changes to app.js or whatever. So I'll just exit it for now. If you want to get container metadata meaning ID, created path, arguments, whatever. So you do a Docker inspect with container ID. I'll use the same container ID. So this is the metadata related to a container. What if you want to get information of a you know, single mapping? Let's say you want what are the device requests for this container. What you do is you mention it here. Let's say you want networks or you want the IP address. So you'll give it as an argument here. And what was the container ID? This was the container ID we were using. Let's just mention it. Okay, so you get the IP address here. So if you want to get a particular mapping inside the metadata of a container, you use inspect and you do a format and mention the argument. Now what did we do? We created a Docker image, we built a Docker image, we ran a container, and we debugged the container. Now we want to publish our image to the registry. Registry is what holds all the images, it manages all the images. So we want to push it to the GCR. This is my project ID. So you create a tag for, let's say, the application that you want to push is point 2. So just mention this. So you've created a tag for this particular, and now let's look at the Docker images. Now you've pushed it to the you've created another repository like this, as you can see here. Now we want to push this image to GCR. GCR is Google Container Registry. We mentioned the project ID here. Our project ID was this. Okay. So it's pushed. It says layer already exists, and this is successful. Now we want to remove all the containers that we built. Docker stop. Docker ps hyphen q gives all the containers to you, all the running containers. So you stop all the running containers and then remove all the running containers. Now what you have to remove all the child images as well before removing this image, right? So that's what we do here. RMI means remove image and RM means remove container. Let's just mention our project ID. Okay, so we've removed the image, we have removed the container, we have removed all the child images as well. Now, as you know, we had pushed the image to GCR. Whatever image we created, we pushed to GCR. Let's try and pull the image from there and then run a container, run that image and create a container using that. So we are pulling this image from GCR and then we are running that image, that particular image that we pulled to create a container. And then we are doing a curl HTTP localhost 4000. And then let's see what do we get. So this is connection. Okay. There should be something else. Okay. So after you follow all these steps, just check your progress after you followed all these steps. So this says that your assessment is completed and your lab is complete. And yeah, so in this you ran containers based on public images from Docker Hub. You built your own container images and pushed them to GCR, and you learned ways to debug running containers and ran containers based on images that you pulled from GCR. So you learned all these things. You can, if you were not able to do it right now, you can just take some time while it gets activated for you and then just follow all these steps. And if you have any questions, you can ping us. Yeah.
And I think that's pretty much it. We're running out of time here. I think, yeah, we'll just stop here. I'll just stop recording.